So I've gotten a lot of questions about, how do I read code? As in, how do I personally read code? But also, like, what can people do to get better at reading code or understanding code or writing code? And initially, I had started writing out a whole script for this, and it started kind of spiraling out of control because the reality is that the way that I read code is pretty dependent on and embedded in my ideas about how education works, how learning works in general. And that's something that we are going to focus on in this channel soon, now that we're leaving this old regime. But we haven't really talked about it yet. And I didn't really want to put the cart before the horse. And it was getting into a situation, the script was getting into a situation where I felt like I was perhaps raising more questions than I was answering. So what I want to do here is just give a few like tips and tricks about heuristically how I think about reading code. And they are the following. So I guess we might as well do this as an org buffer. So here's how I'll set it out. So psychological, computer science. These will be just like little headings just to hang things on. And is there a last one? I don't know. We'll start here. Maybe this will be technical. So how about mental game? Mental game will be first. So the first mental game point is you have to be relatively fearless if you want to do something like trying to understand a code base is kind of a foolish thing to do. Most code bases that are of interest are too large to understand even for one person. If you take something that like, a large company like Google puts out or Meta or Twitter or Netflix, oftentimes those big projects are going to be worked on by several teams. And if you're really lucky, a small number of the team leaders on those teams will understand like one directory. That's maybe exaggerating a little bit, but really things are broken down and specialized, and you don't really have someone whose job it is to understand the whole code base, because it's not clear that even if it were possible, that there would be a whole lot to gain from that. Instead, what the code base does is you've written down into the computer how the machine will act. And so that's really the record of the code base. And then in terms of understanding it, your job is to sort of be able to have a conversation with the computer in some sense about how you want it to act. And so it's maybe a little bit like I have kids. You may not have kids, but it's a little bit like having a kid. It's not really my job to understand everything that goes on in my kid's brain, because literally nobody does. But it is my job to, like, if my kid is having a hard time, be able to have a conversation with them and help them have a better time. And it's kind of the same with code. And in order to do that, and you have to be also willing to be confused. And not, these are related, right? So you have to be willing to, like, as you're looking at something, be comfortable with the fact that you don't understand what's going on. And you see that a lot in this channel. And, very often I'll just say, I don't know what's going on. I don't know what this variable is for. I don't know what this piece of syntax is. And I typically just move on rather than trying to drill down. And that's a strategy. I think, like, earlier in my life, it would have really bothered me that I didn't understand something, because I was very good at understanding things. And so I learned over time that it's vastly better to do a pass where you're accepting of the fact that there are things that you don't understand, even if, they are silly and you've made some sort of mistake, and you would understand it if you had not made some simple mistake or whatever. And then just being okay with that is really powerful. And then I guess relatedly is like think in terms of doing several passes is how I'll put it. So there's a good book here by I think Mortimer J. Adler is the guy. This is not like a like life-changing book, but I think it's a book that's worth maybe getting and looking at. And the idea of how to read a book is just like it's a lot of kids like go to college and they don't have a relationship with literature the way that from high school, the way that you do in college. And when you're faced with like a huge library of literature on your field, like you may be an engineer, there's an engineering literature. You may be a philosopher, there's a philosophy literature. You have to have some strategy for dealing with all of that. And the strategy can't really be like depth first search, where you're going to like pick up Nietzsche and understand everything that's in it. Instead, what you want to do is you want to read books in passes. You want to make a pass through each individual book. You probably also want to make a pass through several books at the same time. So maybe you want to pick up the Nietzsche book, also pick up a Plato book, pick up a book on classics of philosophy, and kind of work through them sort of simultaneously. And so that's a little bit of how I've done things in this stream. It's been rare recently that I've revisited a repository many times, and that's really an artifact of my trying to get through the backlog. But if it were me left to my own devices, I would revisit the same repository that I was trying to understand multiple times, doing multiple passes. And that's useful because when I don't understand something, almost always I find I eventually understand it with little effort just by doing more passes. I may not understand it the next pass. It may take a couple of passes. But that, in my experience, is like the least effort approach to getting the most out of what you're doing. So that's the mental game. We'll hide that for now so we can focus here on kind of psychological points. And the first psychological point is maybe have a sense of how the brain processes information. In my opinion, I think this is now pretty mainstream. The brain is more or less like a machine learning algorithm rather than a traditional computer. So the brain takes like a probabilistic approach. It does a lot of pattern matching, and it does a lot of that, almost all of it, I would say, kind of behind the scenes in a way that you're not really aware of. So what that means is you can kind of imagine that your brain literally is a machine learning algorithm. Look at how they train algorithms and take that sort of approach. So when you're training an AI algorithm to, let's say, understand text, at the end of the training, it's able to quote unquote understand text in the sense that you can ask it a question and it will spit out a response. But kind of in the beginning of the training or in the middle of the training, it doesn't really understand anything. It's like updating a bunch of weights. And if you try to get information out of it, it would be terrible and garbled. And so what that implies is that this algorithm is iterating over a bunch of documents, and it doesn't really understand any one document. Instead, what it's doing is kind of like pattern recognition across a corpus of documents. And that's the same sort of approach that I'm taking here. Is I've looked at a bunch of repositories. I'm not really trying to understand any one repository. Instead, I'm trying to see what things have in common, what things stick out and what are different, and that sort of thing. I guess relatedly is have a sense of what you're looking for in a repo. So if you have if you've gotten to the point where you've looked at a bunch of different pieces of code, then it'll be clear to you, as I just said, what's in common, but it will also be clearer to you what's different. And it's really the differences. You can imagine like literally running a diff algorithm, like a conceptual diff algorithm between two repositories. And those diffs are the sorts of things that you want to focus on. And so, for example, when I was looking at databases, I wanted to know the database type thing, like how are their file systems different from other repositories. A big part of databases are that they're fast to search. So I wanted to know how the querying algorithms worked. And in particular, we'd already seen a lot of like parsing and compiler type stuff. So I was interested more in the query planning rather than the query like parsing and mapping onto specific functions or whatever. So having that sense of what you're looking for will help focus the mind, because especially if you have a bounded amount of time, it'll help you figure out whether something's worth looking at or not. And similarly, if you were like traveling, if you were like going to Paris, you would probably want to go to the parts of, if you, as a tourist, you would want to go to the parts of Paris that are different from all of the other places. You wouldn't like go to Paris and like spend the whole time eating at McDonald's or whatever. The last maybe psychological point I want to make is like familiarity in practice. I'll literally write this down. In practice is often important than understanding. So, and I'll put these in scare quotes because I don't think these are super well defined terms psychologically. The way that I think about it is that familiarity and understanding are kind of like feelings. And what the psychological literature says, in my reading of it, is that often when people think that they understand something, they don't actually understand it. They overestimate how much they understand, especially about technical topics. And so understanding is kind of this emotion that's, in my opinion, really kind of about comfortableness with the topic. And it can often be illusory. On the other hand, in practice, familiarity seems to be really important. There's a famous quote from John von Neumann that in mathematics, you never understand things, you just get familiar with them. That's not word for word the quote, but that's the basic idea. And I think that's correct. Like von Neumann was one of the best mathematicians in the last however many years, arguably one of the smartest people in history. And I think he's correct in the sense that like you sometimes see people trying to chase understanding or like intuition about a topic. And it's often not clear that pays off. That often seems like in retrospect, they are wasting their time. It would be more time efficient to just accept the things that you know about them, become familiar with them, play around with them, explore the tools that you have, but not really try to pay too much attention to whether you feel internally like you've grokked something. And I think that's an important shortcut. Yeah. Okay. And then in terms of technical stuff, this is now kind of getting to the computer sciencey area. One is, so I'm coming to this having already programmed professionally, having studied some computer science, but having studied lots of other technical things, solved many math problems, solved many fewer but still a fair number of programming problems. And so there's just some level of background knowledge that you'll need in order to understand like something as big as a repository. And so I'll say like you should know data structures and algorithms. How much do you need to know them? I don't know, but you should be familiar with them. You should have probably implemented things like depth first search, breadth first search a few times under different different conditions, exploring different problems. And you should obviously know the basics like for loops and while loops and all of that stuff. And if you struggle there, then you're going to struggle reading other people's codes because you just won't have you won't have those patterns very well in your system in order to recognize them in others. So this is just like background knowledge, I guess. You should know some programming languages and have a programming practice, I guess. So this is like, for those of you who are learning how to code and want to read in order to learn how to code, this may be kind of like a chicken and egg problem. But the way that I would do it personally, if I were starting out, is I would have a practice of reading code, have a practice of writing code, and also have a practice of reading information about the topic and programming language I was working on. That could be books. This could be like websites, documentation. It could be videos, and kind of go back and forth between those three things. Like split your time, because those are sort of mutually reinforcing habits. And what you want to really have is the rhythm between those things in order to make the fastest progress, I guess. And then I guess the last technical point I will have is that have an algorithm in mind for exploring the code. I typically do something that's maybe a little bit like iterative deepening depth first search. What you'll see that I do in almost all cases is the first thing I want to know is like which file. So often there's like one folder that has all of the goodies, and it's like the source folder or something. It depends on the language. But like, first of all, finding out the right root folder, but then inside that root folder, looking at all of the folders in there, that's like depth equals 1, and figuring out, okay, which of these looks like it's probably going to have the sort of information I'm looking for. So here, have a sense of what you're looking for. If I have a sense of what I'm looking for, like I know I'm looking for the parsing routine or whatever, then that should hopefully be evident where that is from the first level of folders. If not, or if it's a project and you don't really know where the most interesting code or routines is, then you kind of have to make some guesses. And so you like peek deeper into the folders and try to do the same thing. And you kind of go down bit by bit. And so that's sort of how I think of things. And we'll see that, I think, a little bit in the Blender build system section video. And then the real last, I said that was the last, but this is the real last. There's a point that comes up repeatedly. I'm not quite sure how to put it in writing, but we'll talk about it and then I'll figure a way to summarize it. When I first started, people were asking me about like, why not start at main and kind of like trace through the execution? And after people started suggesting it, I did start looking more at the main file more often. And almost all the time, the main file is not an interesting place to start, because what happens is like main's going to kick off some like often command line parsing routine, and then it's going to branch in a bunch of different directions depending on the command line flags. And then you have to track all of that branching. And then there's going to be like some loading and initialization routines. And that probably has a bunch of different branching because that's also looking for things like what platform are you on, et cetera, et cetera. And so often like going into main and tracking execution in that way is not super useful. And also like if you're tracking in like a debugger, you kind of have to figure out what level you want to debug, because if you like start by setting some breakpoint and if you just stay at the same level, it's equivalent to just reading the code because it's going to execute line by line. If you step into and out of functions, then you're going to like quickly get down deeper and deeper into kind of things that might be implementation details compared to what you actually want to know. And so what I have found is that the tracing the execution is really for the computer. That's how the computer thinks. But the way that code is organized for humans is via the file system. That's how organizations, the file's layout typically reflects how organizations have devoted human resources to writing the code. It's the files are there for humans to put their thoughts into, and then once it's compiled and executed, that's for the machine. So my personal preference, and you can differ here, but my personal preference is focus on the files, focus on the human-facing artifacts rather than the machine-facing artifacts. Is how I'll put that. Now, you do sometimes need to look at the machine-facing artifacts. So, for example, if you want to debug a program that's gone haywire, or if you want to understand the like assembly code, or if you want to disassemble some program, you do have to dig into the weeds. That again goes back to knowing what you want to look for. And so if that is what you want to look for, then like stepping through with a debugger, etc., that's a really good way to look at things. And I do enjoy debuggers. I use them for tasks that are different from reading code, but they're great. They're life-saving tools. I had one more thought, I think. Let me check my notes here. Yeah, I guess this maybe goes into psychological, or maybe I'll call it mental game. And that is, this is closely related to be willing to be confused. And that is, be honest about what you understand. So if you're going to be looking through something and are willing to be confused, then that only works if you're honest with yourself about what you understand and what you're confused about. The danger of not going through something carefully and trying to understand it at every step of the way is that you might fool yourself into thinking you've understood something when you haven't. And that might take practice. I don't know, that might just take some humility. But be aware that you have limitations. Some of these limitations are informational. Like you can think about different ways of trying to understand something. Some of those will have like exponential running time. Some might have polynomial running time. And it's kind of your choice about which of those algorithms to run. But in addition to having like those information constraints, like those sort of running time intrinsic constraints, there's also constraints about like your ego might be involved in being able to solve some problem, or being able to understand something complicated that your friends are having trouble with, or being able to prove yourself, or all of that stuff kind of goes into any topic that's sufficiently complex, or wanting to dig your way out of poverty, or all of that stuff. So you just have to kind of be aware of when you're you have to be aware of kind of when those like emotional responses are making you think that you've mastered something that maybe you haven't mastered. And I guess maybe that's the last point. I'm sure I'll think of more stuff, but for now, we'll leave it here. And I'm going to move on to the Blender build system.